Well, hello everybody. It's good to see you all here today. We are the founders of a project called KubeFirst. We've been working at it for almost 5 years now. We have been through the ringer of Kubernetes and GitOps and IAC and everything for pretty much as long as we can remember in recent history. I am John Dietz. This is my, thank you.
Slides.
Oh yeah, let's do that. We'll do the slide deck. You guys want to do the slide deck? Let's do the slide deck. So we should start by thanking our sponsors. It takes a lot to get on stage. Sometimes it's a bit of a fight. And the fine folks at Civo, we wanted to thank them for sponsoring this event. And wanted to acknowledge KubeFirst for setting a little bit of time aside from a very crazy schedule to put this demo together today. This is my co-founder, Jared Edwards. I'm John Dietz. I have been in DevOps and platform building since before both of them had names. My career has spanned from testing to performance engineering to big data to development to build master to platform building in the cloud, and then platform building for cloud native. I don't say all that to brag, but if you're looking for a voice of authority that comes from a very wide perspective of a lot of different disciplines on how to build a good platform, I think you could do a lot worse than the story that we're going to pitch you. I fell in love with platform building at USA Today. They had the company name is Gannett. They had a conglomerate of 120 news outlets, just enormous scale, cloud environment, on-prem environment. They needed abstractions for their swaths of development teams that just every single team could not know all the ins and outs of that particular environment, and I was just fascinated by it. I loved the scale. I loved the approach that they took, and it's truly the exact same approach that you hear today in platform engineering in 2024, abstracting away the complexity and ensuring security and compliance, and interviewing your engineers that are using your platform to make sure that you're delivering a platform that they want, that they will use, and getting rid of their pain points is not new to Kubernetes. After I was working at USA Today, I got an opportunity to build my first platform from scratch for this company, Remind, where I met Jared and where I met Kubernetes. This is the olden days of Kubernetes, back before there were really any blogs that weren't just full of lies. We had to learn Kubernetes the hard way, just by trial and error. We put a bunch of tools together the wrong way before we figured out the right way to put everything together. And Kubernetes was just different. I'd been in various sections of DevOps forever, and everything was very different with Kubernetes center stage. So much so that Jared and I decided to start working nights and weekends on the KubeFirst project so that we could try to deliver companies with instant value out of Kubernetes from a platforming standpoint, and we wanted to do it in a way where you could take that default platform and then adjust it however you choose. So we've been working at it forever. We piloted the KubeFirst project for a little over a year with an enterprise company, made sure that it could scale, and then we open sourced it after we got everything in a very complex environment running in production. And we then joined the CNCF landscape and got some funding for a very small team, but a great team to try and see the rest of the vision through. And that's kind of the journey that we're on right now. And with that, I should introduce my co-founder, Jared Edwards, the beating heart of the KubeFirst engineering team.
Thanks, John.
Yeah.
I'm Jared, as John mentioned there. I have a different background than John by a good bit, but it still had something to do with platform somehow. My former career was actually being a commercial diver in the Gulf of Mexico, so I was working on oil platforms and taking old pipelines out, and somehow life brought me around to becoming a platform engineer here today. So it's been about a decade of working in the software space and getting out of the oil field. As John mentioned, we met at Remind. That was my very first technology startup, and I couldn't believe how much learning and growth was in that environment. We had really good leadership that really let us kind of spread our wings and take over the Kubernetes platform. But Kubernetes was the fire hose that enabled all of the innovation for that team. So it was great. I was born in the cloud native space, so Kubernetes has been like 95% of my life or working life since I've met it, and that's kind of it for me.
So today we're going to do a demo. We have a README available at the link up here at the top. It's github.com KubeFirst/navigate. And there are a couple prerequisites if you wanted to follow along with this, when you get back home after it's up on the internet. Our README docs are where you're trying to get to that'll guide you through everything you're seeing today. Our goal is that we're going to be able to show you some really cool stuff, and then you can just take everything that we did and use it at your own organizations however you choose.
So,
I should take a quick moment on GitOps and Linkerd. So we're going to do a lot, and we're going to do it really fast, almost impossibly fast. And it's reasonable to wonder how we're able to do it all so quickly. We're starting literally from scratch. We're going to create a multi-cluster joined environment in 2 different regions where the clusters are aware of each other with infrastructure as code that's creating these 2 clusters using GitOps with Crossplane and Terraform. And just, I won't spoil the whole thing, but it's really cool. Linkerd is a big part of the story, though. Linkerd is a service mesh. And a lot of times when people think about service meshes, you're thinking in a mindset of security, and it's true. It provides a really good security model for MTLS encryption, for least privileged network access to your services that you're running in your cluster. It also, however, provides some really great multi-cluster architectural capabilities, and we're going to show a little bit of that today. The reason that we're able to do it all fast is very largely because we buy into GitOps exclusively, and we have this really great Linkerd technology that we're going to be tapping into today for our demo. So Jared's going to show us the demo.
All right, let's get to the live workshop. So John mentioned we're going to come to the README here. I've already gone through the prerequisites for this, but they're all listed here at the top. I also already have the repository. So I'm going to get a new terminal here. Actually, I'm going to use the one that already has big font. That's a way better idea. Let me go to my navigate repository, and I'm going to run a k3d create command. We're going to see how quickly it goes. The internet's a little bit slow, so this is usually about a minute. I think it's about 4.5 right now, so bear with us while we fill the air with a couple of other things. And as soon as this returns, I'll pull up something a little more valuable. So
tell us
K3D.
about the logo on your t-shirt.
It's a great question. Thanks for asking. This is K-Ray. K-Ray is our mascot. It's supposed to represent our frictionless way of navigating the troubling seas of Kubernetes. K-Ray has been a big fan of our hardworking team and vice versa. So.
Yeah. Talk about K3D maybe a little bit?
Yeah, sure. So what we're showing you today, basically, in order to start, one of the challenges that you have with starting infrastructure from scratch is that you have to have some technology somewhere. There's a lot of IAC tools in the wild. You've got your Terraforms of the world, you've got Crossplane, you've got Pulumi, and a lot of the IAC tools are going to use and kick me off whenever it's time to kick me off. Yeah. So a lot of the tools are going to use command lines in order to run your infrastructure as code. You run a Terraform plan, Terraform apply, and then as long as you have some Terraform files in a directory on your local host, then it will turn that into real stuff in the cloud. It's going to create your S3 buckets. It's going to create your VPCs and your Kubernetes clusters and whatever else. Now, with Crossplane specifically, Crossplane runs in Kubernetes only. It does not have a command line interface. So what we do, because we always want to start from GitOps, and we always want to run our infrastructure as code from that Kubernetes control plane, but there's no Kubernetes yet. If the first thing you have to do is create Kubernetes, K3D is a great answer for that. K3D is just a very simple wrapper around K3S. K3S is a distribution that a lot of the clouds are starting to pivot to. It's a nice, simple Kubernetes distribution. K3D just basically wraps that in a container so that you can have a Kubernetes cluster just by running a simple command. So we use it as a starting point control plane very regularly. You don't have to. You could go into a cloud and click create a brand new Kubernetes cluster, and that could be your control plane. But then you have a resource in the cloud that has no backed desired state, and then you have to import it, and that's kind of a mess. So we like K3D to get started from scratch.
It's usually a pretty fast way to get up and running, but as you can see here, I'm still trying to start some containers, so this isn't going off to a great start. Let me maybe just... We're just going to give it another 30 seconds or so.
This is likely just throughput pulling images from...
That's what I'm thinking. This worked in the speaker lounge great, but...
Are you on your cell phone or on the network right now?
I'm on the cell phone.
You're on cell phone right now? We've had a couple trial runs today. The network here is blocking a couple ports that are important to our exercise, and we got through a tethered operation earlier today. We think that this is, as soon as we get out of K3D and into our permanent cloud space, we expect everything's going to go very smooth. So bear with us for just a couple minutes here.
Yeah, I'm going to go manually create one in the cloud also, and if it beats me, then I'll just move our demo to a Civo cluster.
Yeah, let's do that.
So let's go to Kubernetes really quick, create, and let's just call this thing local. We can bump this down and throw a large node, create. We'll see which one comes back first.
Should I go get Mark and Dinesh to tell them we're at the race?
Yeah, racing K3D. So I guess I can talk a little bit about the architecture that we have here based on what was supposed to be happening. So we have this K3D cluster that's supposed to be running locally, and then in that K3D cluster we need a few things. The first thing we're going to add is a Civo token. We need to be able to have permission to create stuff in your cloud account, and then we're going to install Argo CD. It's going to be self-managing itself in that K3D cluster through GitOps, as well as we're going to lay in a Crossplane system as well as the Terraform provider for Crossplane. What that'll give us the ability to do is invoke a Terraform module that we have behind the scenes that is going to be what creates those Civo clusters in the cloud that are going to be in those London and New York City regions. And we're getting somewhere. It's going to install Argo CD though, and it's going to slow way down. So let's see, 76 seconds on Civo. We're betting on them, I think.
While we're killing dead air, I guess we probably could take a moment just to explain GitOps a little bit. It's certainly not new to the industry, and I'm sure it's been popularized enough that most people here are familiar. Just quick show of hands, are you using GitOps at work yet? Anyone in the room? Okay, all right, good. So quick explanation on GitOps. Thanks. GitOps, when you have a Kubernetes cluster and you're trying to get applications into that cluster, Kubernetes provides you with a CLI to let you do that. You can run a kubectl apply, and you'll have some YAML files that you can just like push into your Kubernetes cluster. And a lot of people, when they build applications and they need to deliver that application to a dev stage prod environment, they'll do that through CI. They'll write some scripts in their CI, and they'll have some directory in their application repo, and they'll just kubectl apply through CI the creation of an application in their Kubernetes cluster. Alternatively, though, and it doesn't have to be a kubectl apply, you can also run like a Helm install command if you want to wrap those Kubernetes manifest files in a Helm chart, which is a nice delivery pattern. But instead of doing those imperative commands of a kubectl apply or a Helm install, what GitOps does is it changes the rules a little bit, and it says, hey, let's not imperatively run commands to get content into a cluster. Instead, let's define a configuration Git repository that has the desired state of everything that's supposed to be in every Kubernetes cluster. So with that, what you get to do is you get to marry your Kubernetes engine and your Git repository with a binding using a GitOps engine. There's a handful of GitOps engines out there. We use Argo CD at KubeFirst. We love Argo CD. We think it's just a phenomenal technology. We understand that Flux CD is also a very capable, very frictionless GitOps technology worth looking into. And if you're looking for the right way to navigate the seas of what GitOps is in a vendor neutral way, there's an open GitOps tag in the CNCF that sort of clearly defines very intentionally in a vendor agnostic way what the GitOps discipline is and how it works. How are we doing over here?
Not great.
Not great.
Yeah, I mean, I think we're still going to get it done. We've got plenty of time, but I can't run kubectl commands on either Wi-Fi network. Can you pop up your tether real quick and try yours? Because that's third network's a charm, I guess.
Yeah.
Sorry about this, everybody. We had really good luck just in the other room there.
All right, Fox 545 is yours.
Let's try it.
Thank you, Fred.
That's great.
All
All right, we're on this network. Let's just watch pods really quick. Hopefully these ones are starting up a little bit faster, being in a cloud cluster, but my commands are just slow.
Just hanging.
Slow.
Color of your terminals. Are there any software minimum versions that you need to be able to do this?
Software minimum versions. Software or hardware?
Software.
Minimum versions in what regard, if I could ask?
The tool set that you use here. So minimum version of K3D, minimum version of Argo CD, or do you just recommend them full latest?
Yeah, no, that's a great question. So you doing all right?
Yeah, I'm doing great.
So the K3D version that you would use is that control plane, or if you wanted to start with a control plane in the cloud, with a Kubernetes cluster in that cloud, we do recommend that should be the minimum, the latest available version. Once you're talking about GitOps, though, and binding a GitOps repository to that Kubernetes cluster, the GitOps repository itself is going to have all of the versions of everything that you're creating. So when you're creating infrastructure, that GitOps repository is defining what version of Kubernetes you're going to create. For Argo CD, which it's going to install next, it'll have the specific Helm chart version that it's going to be installing. And then it just kind of continues to unfurl once Argo CD is in control of the provisioning of your applications. So we use a technique called Argo CD sync waves in order to control the order of operations of what applications are being installed. Basically, there's this GitOps repository that you must have. Now, the KubeFirst project, which is not what we're demoing here, the KubeFirst project will build that GitOps repository for you and then host it in either your GitHub or your GitLab account. And that's how you get the creation of your infrastructure. And it's also how you're able to adjust that infrastructure to be whatever you want it to be. So you could, from that starting point, upgrade to new versions of Linkerd, or upgrade to further along versions of Cert Manager, or external DNS, or any of these micro products that are in a typical cloud native space. We're doing good?
Yeah, so I'll take it over.
Please,
there.
Right back to you.
The cluster finally came up healthy. Argo CD was installed, so just created a secret here. We're going to port forward to that new Argo CD instance. And I don't have my helper command, so give me just 1 second to update this terminal also. Perfect. And now we're going to get the Argo CD password, maybe. And perfect, that is the password. We're good. And let's go to the Argo CD UI. So now that we can actually visit the UI, we can show a little bit of that unfurling that John was mentioning through our Argo CD sync waves. So now let's grab this command here, and we're going to apply what we call a bootstrap YAML. This bootstrap YAML is what is going to install those resources I was mentioning just a minute ago, Crossplane, Terraform Provider, and Argo CD itself. So let's jump into the UI and watch that happen, hopefully, if that ever makes it across the internet. Love live demos.
We are stubbornly committed to live demos. We think that our audience deserves nothing less than us struggling and sweating.
Yeah. I can disconnect, but everything's slow. I'm just going to patiently count. Go ahead.
Question on the Argo CD. You deployed Argo CD as a container on the KubeFirst. How would Argo CD get access to all of the Kubernetes resources so that it can control the deployment?
So
Argo CD is, well, it's actually running in a cloud cluster, so forgive me if I'm interchangeably saying K3D and cloud, but once it's running in that cluster, we actually have an upstream repository called Manifest that has our setup for Argo CD. There is a configuration in the Argo CD config map that has to be adjusted for the sync waves to work in a certain way, and other than that, once if I can ever get Bootstrap to actually get into the cluster, I would immediately apply a registry, as we refer to it, and I'll talk about that in a second. But those two clusters that would be getting provisioned through the Terraform provider are going to then write their secrets and kube configs back to the cluster that was doing the provisioning so that they can be registered in the Argo CD UI. So after it's installed, you'd be able, and once those clusters create, when you visit the settings section, it would usually show you a list of things, and those two clusters that we just created would be those two additional things for Argo CD to be able to manage those. But this is, highly recommend anyone who's in this room tomorrow not do live demos. I have, let's see if I can just drop the YAML in the UI of Argo CD and skip this. Sorry about this, everyone. Just give me a second here. Let's do Bootstrap and Bootstrap. Copy. Let's go to applications. Man. We should have had that GIF of the whole thing handy. That would have been really good. I can try different networks. I'm hardwired to the network and can't even run commands.
Hit Fox 5.
Try again?
Yeah.
All right. I have to have Fred queue up some more elevator music. Thank you, Fred. Thank you for your patience, all.
I'll get that GIF ready.
All right. Man. Oops. CDPF is an alias I have to capture that Argo CD port forward, so it looks like we just got that back. Let's grab that raw YAML and see if I can get Argo CD to do anything. Let's go to edit as YAML and paste that. Let's hit create. Maybe we can bypass the need to kubectl apply something, which feels odd, but
So what's this YAML doing?
so what the YAML is supposed to be doing is yeah, sorry about that. That's very small, so that's better. This YAML is the very first iteration of that registering Git content with Argo CD so that it can deploy it to the cluster. So what this will do is look at this path here in the Navigate repository, 2024 Austin Bootstrap. And what that's going to do is make Argo CD aware of itself and that it has its own app, as well as then install those two additional apps, which would be that automated infrastructure as code that we just can't quite get running. We are now dangerously not going to make the demo, the whole demo. Let's see.
If you're new to Argo CD, there is a talk in that room before lunch tomorrow with better speaker.
Yeah, please go see Fred's talk tomorrow. His is going to be great. And What shall we do? So should we just talk through what it would be?
Yeah, let's talk through.
No. Sorry, we can just go to our other stack.
Oh, great call.
I've tried mine, his. I'm hardwired, and I've tried just the Wi-Fi. I'm kind of out of touch. That's okay. We're gonna just switch. So let me go ahead for a second.
When we were getting set up for this, just in case anything went sideways, which should not be your expectation, we set up a stack that is in 2 other regions. For the just in case we needed to lean on it for the demo today, so we could at least show traffic switching and how to do that in Linkerd. So we're just going to pivot over to that since for some reason we can't get this bootstrap YAML. Can you maximize?
Oh. I also am on. I just disconnected the VPN. I tried that also. I felt pretty good. So let me just think for 2 seconds and go CD pass here.
Thank you for the comparison. I appreciate it.
Yeah. All right. So,
say again? We have not tried SSH tunnel. But I think they're blocking port 22, so I don't think that will go well.
All right. Well, so when you were when I applied that bootstrap, what was supposed to happen was this was supposed to end up in your Argo CD UI. This is the same set of folders. So I mentioned Argo CD is managing itself. So anytime you want to make any additional configuration changes to Argo CD, you can go in the repository, and it's a customized implementation, so you can add your customizations. And then the other 2 components would be Crossplane, and the bootstrap app there is literally just watching that directory for any new content, and then you can see the Crossplane provider and the Crossplane system here are running. So in light of that, we also have already applied the registry here. So these 2 clusters were created through the same exact workshop. You can actually find them in the registry-backup folder. So if you were to follow the README in that directory instead of the registry directory, you'll have the same experience. These 2 clusters are running in New York City region named Denver, and then the FRA1 region in Civo called Dublin. So those are the 2 clusters that we'll be referring to for these, and please just give me the UI. I even have a backup stack and I still can't do it. So let's just go visit Metaphor for a second. So I'm going to drop back to my README and talk through this diagram here. So what I was supposed to get to eventually was this registry. Registry is just a set of folders that has those sync waves that John was mentioning that Argo CD understands how to lay into the cluster in the correct way. So you can go to the repository and explore how those are laid out. And then the components that we're putting in there are going to be very first Linkerd control plane, and we're going to wait for the Linkerd control plane to be healthy. And then we're going to install Ingress Nginx, external DNS, and Cert Manager. We usually install those 3 tools to all of our clusters that we end up using everywhere. It gives you a really nice way to manage your TLS certificates and also automate your DNS deployments or DNS host names in your cloud account. There's also an application called Metaphor. So I'm going to click on this to blow it up a little bit. Metaphor is running in both of these clusters in Denver and Dublin, and there's very few things that are different about it. Whenever we're talking about application delivery in Kubernetes, we always want to make sure that the configurations are being passed into the container to give it any of those environment-specific things, so we have an easy way to override. So there's a couple of highlighted sections. You can see that this one's, it's going to be called Denver Metaphor Development. Our demo didn't go so well. And then you can see the paths that are registered for the Metaphor application, and it's referencing a file called New York values. The middle picture there is going to be what it looks like to have that Metaphor Helm chart that we have those custom values applied to it so that it can run in both clusters showing different things. And then we have an ingress object that's going to have 2 host names. We have a vanity of metaphor. It's going to be gitops.biz, not GitOps Magic, yep. And London will have one of those. So if we want to explore what those actual Metaphor instances look like, we can go to Metaphor Dublin, and I said GitOps.biz. I think no, I said
GitOps.biz.
No, that was in the wrong region. KubeFirst.com.
Oh, right.
Wrong account. So this is Metaphor. It's a very simple app. There's not a whole lot going on. We're visiting the Metaphor Dublin. Let me blow that up a little bit. Metaphor Dublin instance. So this is running in the FRA1 region. If we go to Metaphor-Denver, metaphor.kubefast.com, we will have the Denver instance of Metaphor running. So if you see that box that's 3 down there in the Kubernetes config section, we have those configurations intentionally overridden to show which instance is serving traffic. Oops, sorry. So these guys here are what we're using to denote what's going where. So if I visit that vanity of metaphor.kubefast.com, we can see Denver is what's being served on the vanity. So let's go to the README here, and I'll kick it over to John to talk about some network architecture real quick.
Yeah, so I'm going to have to blow through this. We talk kind of simply about Linkerd like it's a single thing. Really what we're doing is we're installing 5 different Linkerd Helm charts. It's the CRDs so that you have access to their types, multi-cluster for the multi-cluster capabilities. The control plane is the Linkerd guts itself. And then we use SMI. That allows this same workshop to work for you in different clouds, different regions, whatever you want it to be. So there's 2 different network topologies that you can have with Linkerd. And the SMI implementation is the one we're doing so that you can leverage that in different clouds, specifically with the Ingress Nginx technology that we're using for Ingress. And like Jared was just describing, we've got a Metaphor vanity URL, and then we have specific ones for the specific clusters that are going to each respective cluster. And we have the New York City one running 100% of the load to itself. So there's no cross network communication going on. But once we implement a traffic split object to the Kubernetes cluster, we're able to change that to a 50-50 split so that you have 50% of your traffic going to the cluster that you started in, and then another 50% going to some remote cluster somewhere else in some other region, in some other cloud. And the reason that you would want to do that from a practice standpoint is, like, let's say that you have a production cluster and it's got all of your workloads in it, and you have to do some major risky operation. You have to upgrade major versions of, all of your stuff. You have to do Kubernetes and Argo CD and Vault, and all these technologies need just like full, maybe there's breaking changes and you're worried about it. Whatever the reason, you want to have another cluster and you want to safely test out that it's going to work well with your workloads before you move 100% of your traffic over to it. This implementation makes it really easy to do that. You can just set up another cluster, make it identical, upgrade it the way that you want to upgrade it, and then you can shift traffic to it at the service layer using the traffic split.
And we'll go back over here for a second. So now we're going to get to that link command. I'm going to have to change these just a few lines because of a bad copy paste in the here, but let's go. We're going to actually change this. The next step here is that we're going to change the Denver. We're going to link the Denver cluster with the Dublin cluster, and I'm going to stop talking so I can actually get those words typed out for a second. Thanks. And we're going to apply the configuration that Linkerd generates to the Denver cluster, and I'm going to need one more thing before I can do that, which is the kube config for that. So give me just 1 second. And Denver is New York City. Please just give me kube configs.
I know.
It's been brutal.
That 1 second pause.
I know. And now we got FRA1 for our other cluster. I'm going to copy that link command that I just edited up top and kubectx Denver and run link. Ooh, that didn't look right. I don't know.
Yeah, you have
Oh, I'm missing a Linkerd command on that, aren't I? Linkerd in context. Thank you. Oh boy. This is all my fault. This isn't the internet's fault. Just 1 second there. All right, I think I got the rest of those. So now we're going to run the link command. No objects passed. Wow. Bear with me. I'm going to open a code editor and make sure I didn't botch something there. Maybe. This is Denver.
There you have 'em.
Oh, well, that's why, because I have a bad cluster name of London. Did you say that, Fred? Thank you if you did. Dublin, that was supposed to be. So Denver applies, creates the config for Dublin and applies it to Denver. Now we're going to try this one more time.
Just give us one traffic switch, baby. We got this.
Yeah, we've got eight minutes. We got lots of time.
Perfect.
So now that we've created this link or run this link command, that's what is going to register Linkerd between the two clusters and make it self-aware. So if I go look at the development namespace here and I get service, we can see that there's a new service as of 7 seconds ago. So what that did was that actually created a service that's being mirrored in your Dublin cluster. So to actually use that, let's get rid of this now so I can stop flipping around as much. And we go back to the walkthrough here. I'm going to need to make one more change to words. And then we will be on our way with traffic split. Denver, and this is Dublin. And this goes here. All right, we have a traffic split created. So now when we go back to visit that metaphor ingress resource that was serving the Denver traffic, as we can see on the screen, when we refresh it, it's going to be serving the Dublin traffic. So in this initial traffic split, what we did was added 100% of the traffic from Dublin to Denver so that we could just immediately show you without having to refresh the browser a whole bunch. But now that that's working, we can at least go back to here and we can adjust that to be whatever we want between those two cluster services. And now we have it configured 50-50. So if I now refresh this page, you're going to see that Linkerd will intelligently be able to switch the traffic between the services through that link command. And that's the traffic switching we were trying to get to. So
yeah, and just to call out that this demonstration here is switching traffic at the service layer, which is an important distinction. You also have, as we described, a vanity DNS that is pointing to either one cluster or the other cluster, and two explicit DNSs for each one so that you can proactively target Dublin or you can proactively target the other cluster. And you can change how traffic gets into your cluster by simply changing host names of your ingresses so that the vanity URL shifts to the other network. Then you have to wait a little bit for DNS to propagate, and it's not going to hit everybody at the same time, which is what's nice about controlling traffic switches at the service layer, is how instantaneous it is. You've got Linkerd that is at the controls of the gate of traffic, and it has the opportunity to say, hey, I know this is supposed to go to Metaphor in New York, but I'm going to send it over to London anyway because that's my job. So even though you have ingress going to one cluster, you can shift that traffic back around to another cluster, test things out slowly, make sure that everything is good, make sure your error rates are where they need to be, your SLOs are where they need to be, and then once you're satisfied that that cluster with its new configurations is ready to go and ready to serve 100% of your production traffic, that's the appropriate time to shift your ingress level traffic over to that new cluster, and then the old cluster is completely disposable to you.
So that's it. That's the end. I actually was able to finally apply this bootstrap to the local K3D cluster all of a sudden. So I don't know what's happening there. If this is healthy in the next 30 seconds, I'll apply that registry and just kind of show that in the works. But if not, oh, that was Denver there. I'm on a different Argo CD now. So not sure what happened there, but yeah, I was going to pull up one more thing to show. Let me just go back to my other cluster. I've botched all my terminals with too many clusters now. Come on, kubectx Denver and see. Nope, sorry, that's local. And nope, backup. Sorry, wrong. That's 6 clusters in 40 minutes. I'm trying to keep track of. CD pass, CDPF. Man, and I have an open one here. Let's kill that. And localhost. Just 1 second. And all we're going to show is what is inside those clusters that would have been hydrated on in the orchestration there. So these are all of the Helm charts that would have ended up being delivered to that cluster. They get orchestrated in a way that we described, but I forgot to show that all these things are actually immediately installed to that cluster as soon as it's ready. So it's a great way to deliver, I don't know, what is that, 13 Helm charts? Just
what you could show is we could deregister one of the clusters and show the reciprocal of it tearing it down backward. Sure. And that would be just just as valuable from a GitOps orchestration standpoint.
All right, so we'll make one more commit here, and then you're all free to go. And you're still free to go, but
Lock the doors.
yeah. Let's comment this really quick. So this is the equivalent of deleting this file, but let's delete Denver cluster, and commit that to the main branch, which is bad practice. Fred's going to yell at me later, but don't worry about it. And if I go back to my registry application here in Argo CD and hit refresh, Argo CD is on a 3-minute poll, so I could have waited those 3 minutes, but just to force this along and show kind of what's happening, you can see that because we've deregistered that registration, now Argo CD's job is to pull all of that content out of the cluster. So it's going to, in the reverse order of the sync waves, uninstall each of the components that was added to that cluster, and then it's going to get to this with this one right here that's probably going to hang out for just a minute. That's the infrastructure deprovisioning, and that takes just another couple seconds. But this is the sync wave orchestration that we were hoping to show in the other direction, but at least you got to see a little bit of it, bootstrapping a cluster and then getting rid of the cluster all through just commit.
Yeah, and that's truly what's got our passion just burning for GitOps and IAC and bridging that gap between infrastructure as code and GitOps is just now that, you know, with the extension of Kubernetes into CRDs, and then with the evolution of being able to manage not just Kubernetes objects in Kubernetes, but literally anything that you want. Infrastructure, you could wire it into a smart coffee maker if you needed to. So being able to have that in a desired state in a Git repository and be able to ship it around between clouds, be able to ship it around between a K3D cluster versus a cloud cluster, DigitalOcean, Civo, AWS, GCP, it's all the same. You've just got a directory of the stuff that you want and you can apply it and turn it into reality. So yeah, that's as good a shot as we've got.
Yep.
And just wanted to call out the ability to create a full KubeFirst cluster. You know, this particular workshop has no KubeFirst components in it at all. It's all just good old-fashioned YAML from open source tools that are in the wild. We have on our KubeFirst project, it has all of this stuff in it, but it also has the ability to create containers, Helm charts, deliver to a development, staging, production environment. We have cluster management where you can create additional workload clusters and manage the lifecycle of those clusters. Application management, we have a GitOps catalog that allows you to pick from a whole bunch of other valuable cloud native applications, but we'll do it in a way not like the other marketplaces that you're used to where Helm installs or kubectl applies. This will actually bind it to your GitOps repository so that you have that permanence forever, so that you have that automatic disaster recovery and everything that you need. So we hope you'll check us out. I know it was a little bit of a bumpy demo today. Thank you for your patience and the questions to fill the airtime. Yeah. And it was a real pleasure presenting to you guys today. Thank you so much for coming to our talk.
Yeah, thank you.